So section 1.3, finding limits from graphs. And this one talked about these one-sided limits. So I'm just going to real quick go through the notes that you saw on the video. I'm not going to spend too much time unless you have questions, of course. It's one-sided limits is the y value a function approaches at a given x value from either the left or from the right. And if it's coming from the left, you get a little negative sign after it. And if it's coming from the right, you get a little plus sign after it. So you're looking at from the left or from the right. So they give you an example that he talked about right here. If I'm coming at 3 from the left, then I'm coming from the left-hand side of it. And I'm looking at what is the y value approaching as I get close to 3, and the answer is -1. But if I come at 3 from the right, now I'm coming this way. So now if I'm looking at it this way, my y value is 2. And so that's where these things were going. We're here with the examples that he gave. So from the left with the little negative sign was -1. From the right was 2. But then he asked, well, does the limit exist? And the answer is no, because it's approaching two different y values, and it has to approach the same y value in order for the limit to exist. So although the left-hand limit existed and the right-hand limit existed, when you put it all together and look at 3 as a whole, it doesn't exist because they're not approaching the same y value. Then he went into an example here where he used the graph and you just evaluated. That was just like your homework problems from last night or from section 1.2, and I believe you probably had no issue with any of that, but you can stop me if you did, and I'd be happy to answer. But then you get to this guy. Now this was where this gets a little dicey. This gets a little harder. So they want you to sketch the graph, and you have to have all these qualities in the graph. And so you start with whatever is most concrete out of all of it, and that's the coordinate. If they give you a coordinate, you want to start with that place. So I know that when x is 3, y is -1, it's a solid dot. There it is. So go with the easy part first. And then the next thing you want to do, the next thing you want to do is look at the limit here. The limit at 3 is 4. So when I'm at 3, now notice you already had a solid dot there, so you want your 3 to be an open circle because it's a function. Got to pass the vertical line test. So you know if this guy's closed, this guy has to be open. So I put a circle there at the value of 3, 4. And all I know is that the limit exists. So when I start doing this, I just put a little line off to the side of that and a little line off to the side of that on either side, so that I remember that the limit's we're going to do an example problem together and I'll show you what I'm talking about. But I just do a little bit to one side, a little bit to the other side until I figure out the rest of what they're asking me to do. Come down here. When I approach -2 from the right, I get a y value of 1. -2 from the right, get a y value of 1. So here's my open circle again. I'm not sure, it may close later, but for now it's an open circle. Then it says it's increasing from -2 to 3, so that means the graph has to be going up between -2 and 3. And then it says the limit at -2 from the left is bigger than the limit coming from the right. So the limit coming from the left has to be a taller y value than the limit coming from the right. And then I kind of put it all together so it looks like a function. You could also have, like over here on the side, you could have this curvy. You could have it look more like a parabola than a straight line. There's a lot of different variations to this. So there's not one concrete right answer, except that all of this criteria has to be accurate in your graph. So I could definitely make this more curvy, more like a parabola, or change it up just a little bit. Yours might not look exactly like mine, but they should all have that same, we should all fit the bill for this. All right, questions on that, because that's a hard question. All right, then we're going to look at the practice problems. We're going to do some of these together. Let me grab mine. So if you get to the practice problems for this, the ones that I want to do, I'm going to start with number 3. So practice problem number 3 is this graph right here. In fact, I'm going to give you a minute to answer that because I think you know how to do that. So practice number 3, see if you can get that one. All right, let's see how you made out. A is 1, B doesn't exist, C is 1, D doesn't exist, E is 2, F is -2, G is 1, and H is 0. And again, the biggest thing for this section is making sure that you're looking at whether it's a coordinate that you're looking for or whether it's the limit that you're looking for, because they're a little different. So number 3, questions before we go on? Cool. All right, so now we're going to number 5 is the next one on our list. This is one of the hard ones, one of the ones we got to really think about what it's asking. So we're going to take one piece at a time and see if we can put it all together. First thing I see that they give me is they give me a coordinate. When x is 1, y is 3. So when x is 1, y is 3, I'm putting a solid dot there. By the way, you might want to do these in pencil or something that you can erase. These are definitely those kind of questions, all right? I have an erasable pen that's my friend for this. All right, so this is checked off. I got this part. I got the coordinate. So then I go to the next thing that it tells me. And I kind of look down the line because sometimes they might give you another coordinate that you can take and put into play, but in this case they don't. But everything's a limit, and such that we're looking at. So I go to this limit question. It says when x is 1, I have a limit at -2. So I know at 1, -2, I have a limit that exists. So I'm putting an open circle with a little off to the side, see, just a little dash off to the side on either side of that, because I know that the limit exists. So as I come from the left, as I come from the right, I must get a value of -2. All right, that takes care of this so far. Then I have this that says as I approach -3 from the right, I have a limit of 5. So -3, 5 is going to be a significant place for me. 1, 2. Okay, so I'm right here. Again, I'm open circling for now. And this one only says when I come from the right. Now, if I come from the right, that means I'm coming from this side. I'm coming from the right. I get 5 as my answer. So you see how I put 2 dashes here because the limit was on both sides. On this side, I only put the one on the right-hand side of it because it's only coming from the right. All right, that takes care of both of these. And now I'm at D. D says my function g is increasing only between -5 and -3. -5 and -3. So it is increasing over here. -5 is here, and it doesn't matter where you put it, it just is increasing from -5 to -3. So any kind of increasing, you could have made yours not necessarily in the exact same place as mine, but is increasing there. And then it's also increasing from 1 to infinity. Well, remember down here, I come from it's not going to come from this point to be increasing. It's got to come because the limit exists down here. So I'm going to erase my little dash, and I'm going to make this thing increase for the rest of the graph. Now I'm going to make mine like a parabola just because I want to. You can make yours a straight line. Okay. Now I've got the limit as I approach -3 from the left is bigger than the limit as I approach -3 from the right. All right, -3 from the right, if I approach -3 from the left, I get a larger value. So that means it's got to be something, the y value has to be bigger coming from the left. So it means I'm going to put a circle up here. One of them has to be solid. It doesn't really say which one. I'm going to choose this guy. And that gives me coming from the left. Now think about this. Remember it had to be increasing here. It can't be increasing anywhere, and it can't be increasing only in those two places. So this one has to be a decreasing kind of thing. Why am I confusing myself here? So let's see what we've got. I got a couple things going on that I need to fix here, or complete. Anyway, I have, so I'm increasing only from -3 to -5. I'm -5 to -3, so that's an increasing. So I'm going to, it's only increasing there, so that means I've got to turn this thing around, right? But I can't because that guy already did. I'm fouling up because, you know what? Is it going to pass the vertical line test? Do I have a function? Check me out.
Hey, Miss Winter.
Yeah.
Wouldn't you just have to do like the point at -3 to 1, like the two open circles? Would you just connect those?
That's what let me show you my answer when I did the answer key. It's much prettier. And I did exactly what you're saying, Griffin. That's exactly it. I just need to, now one of these needs to be open, one closed. It doesn't really matter which one. So if I'm increasing from -5 to -3, and I've got, the only thing that I'm looking at is -3. I have an issue with this one too. Are you seeing it? I'm seeing it. Where's my pen? If I come at, let's go through on this picture. There's one problem that's in the midst of this picture. I'm going to see if you can figure it out. But let's go through the things. I've got a coordinate at 1, 3. So here's my coordinate at 1, 3. There it is. Then I have a limit that exists at 1 that's -2. And we said it had to come both ways. But remember, to the right of 1, it has to increase. That was this guy down here, this part. I have a limit as I go from -3 from the right is 5. That's where I'm looking at this picture and saying, wait a minute, I'm a little too low, right? I need to move this up a notch because this is at 4. So if I approach -3 from the right, this should be up another, up a little bit. So it should be a 5. Which means that this guy here has to be higher. So I just needed to move that up a notch. -3 from the right is 5. Yep, that works. I am increasing only from -5 to -3. And my limit from the left of -3 is bigger than my limit from the right. So bigger than my limit from the right. And does it pass a vertical line test? And it does. I've got an open circle, closed circle at all those locations that have issues. So these are much more challenging trying to work your way through them. I'm going to give you one to try in just a second, see how well you do with it. If you flip over to, actually no, they didn't give you one more to try. Here's one on the corrective assignment. Now you might not have this printed out yet, and that's okay. Just grab grab a blank piece of paper or something like that, and just set yourself up with a coordinate plane, and see if you can do this. Yeah.
Sorry, we didn't do number 4 together. That's on the paper. That's what you were looking for.
I was looking, but I want to have you have one homework problem that's going to be.
Okay.
That's right. Yeah, you're exactly right though, Grace. Yeah. I looked at that and I was like, oh, number 4, but then that gives you nothing for you to try on these on your own. So this one says, this is again, it's on the corrective assignment 1, but you can just do it off to the side somewhere. You've got f of 3 is 4. You have the limit as you approach 3 from the left is 2. The limit as you approach 3 from the right is -4. F of -2 is undefined. And the limit as you approach -2 from the left has to be bigger than the limit as you approach -2 from the right. So I'm going to give you a minute for that challenge and see how you come up with a picture. And I'll do the same thing. We'll see if we get something somewhat similar. All right. Do you have a guess? Still thinking? I'm going to double check mine. Let's see. You need to go through the list after you create your picture and make sure that you've hit all the points that you need to hit. So that's what I'm going to do next. F of 3 is 4. I got a coordinate. As I approach 3 from the left, I get a value of 2. So 3 from the left, I get a y value of 2. If I go 3 from the right, I get a y value of -4. F of -2 is undefined, so you need open circles there. And the limit as I come at -2 from the left is bigger than the limit as I come from -2 from the right. All right. So here is an example that would work for this particular one. Is it the only way to do it? Absolutely not. There are multiple right answers to this. So you just need to go through in the end and make sure that you've hit all this criteria. I think honestly that one was a little bit easier in that when they tell you where it has to increase or decrease, that makes it a little bit, for me anyway, it makes it a little bit trickier. We ready to move on? Okay, so we're going to go, that's really all there is to say about that section. I'll come back with due dates and such for that particular set of problems. We're going to look at 1.4, and this one was all about, you're going to need your calculator or something that will give you a set of table values for this one. Because now we're going to be looking at limits coming from tables. I found this to be extremely easy, this section. The hardest thing we did was the hardest thing for the lesson today is what we just did. But if you're looking at, these are now the notes that go with section 1.2. I mean 1.4, my bad. 1.4. So it's same idea, you're taking limits, but you're looking at them from table values rather than looking at it from the graph itself. So say you didn't have the graph, they kindly gave you the graph so they could give you a comparison. But really, you don't need the graph at all if you've got this table of values, because you're looking at what is the limit as you approach 4. Well, if you approach as you approach 3, the value is 4. So as I get closer to an x value of 3, what's the y value doing? And it's going to 4, and I can see the same thing here from the chart. If I get really close to where x equals 3, that would be right here, I can see that my y value on one side is at 3.99 and the y value on the other side is 4.01, and so I can say the limit is approaching the same value on either side, and therefore my limit equals 4. So the second one, according to this chart, now my x value that I'm concerned about is at -4. So if I'm looking where x is -4, that's right here. What are the y values doing to the left and the right? To the left it's 2.499, to the right it's 2.501. So right in the middle of that would be 2.5, and that's what your limit would be. Same thing goes for number 2. If I'm looking for what the x value is at -2, the y value on either side is close to 21, and that's what you're putting for your chart. So questions to there. Then he got out this fancy pants calculator, and he was doing all sorts of crazy stuff with it. Really, here's what, do you have your calculators handy? Take a second and grab them.
Do we need the graphing calculator or our other ones?
You need either. I'm going to show you, I think I'm going to show you how to do it on Desmos because it's really easy on Desmos too.
Okay.
But we're going to look at our graphing calculators as well. The one thing that he did was change, and it's good for you to have it in the mode that he had it in, where you can input your own values for the table. So I'll show you how to do one of these from using our calculator, using the 89s that y'all have. John, did you get yours? Did you pick yours up?
I did.
Ah, sweet. Then you know what I'm talking about. Okay. All right. So here's what you want to do. you want to put this function, and these are kind of new to you, these calculators. So I want to put the function, I'm going to do number 2 up here that you have on your sheet. So we're going to put that into our calculator. You hit this reminds me of Gatorade. Like, is this green or is it yellow? I don't know, but it's the one underneath the blue second button. And then you're going to hit F1. And it should give you a y equals. And we're going to put in the function that we're talking about. So you need parentheses because it's a fraction. So you're going to start with the parentheses. And then it is x cubed, x caret 3, minus 4x caret 2, minus 7x plus 10, and close those parentheses. Now if I go too fast or whatever, you holla. But then I'm dividing that by parentheses x plus 2. Close those parentheses. So here's what you've got in the bottom of your screen, and you're just going to press enter, and it goes right on up into the Y1. And it's kind of cool because on this calculator it literally will show you, so you can compare what you input, make sure that what you input is exactly what you wanted it to be. You know how in the other calculators in the 83s it just kept it all horizontal. This one shows you what it would look like, and you can make sure that you put it in correctly. All right, so are you ready for the next thing? We're going to go to the table. Actually, let's go to table set first. So back to the Gatorade button. Is it yellow or green? What's your choice?
Yellow.
Yellow, okay. Yellow it is. All right, so yellow, and then F4, table set. And it should be blinking on you. The ask should be blinking. If it's not, you want to do a right arrow and you want to highlight the ask. You want it to be in the ask mode, not the auto mode. So it's a right arrow to get to this down thing, and you want to make sure that the ask is highlighted and press enter. All right, so let's go to then back to the yellow button and F5 to the table. And then you can put in whatever values you want. Now we put in negative 2.1. So if I put in negative 2.1 and press enter, that's going to give me out that 22.01 that I was looking for. If I put in negative 2.001, now I get 21.01, and I can get all the values that are on the table that you have that he did. Oh, we got a lot of greens. Oh, look at that, the debate. Green or yellow? I don't know. It's Gatorade. I always thought that Gatorade thing was yellow, and my daughter says it's green, so I don't know. You know the one I'm talking about. I'm sure you get the idea. All right. Got the idea of how to make a table from your calculator. We'll do another one in the practice problems, but that's where you're at with that. Now these got a little different, this last example, and it got me too. It wasn't just taking the value from the chart, it was using the value from the chart. The chart represents f of x. It represents this piece right here. So really what it's saying is f of x, it gives you a value out at 2 of 5. So you need to put a 5 in this place. That's going to give you this. The limit as x approaches 2 of the cosine of 5. And so what you need to do is go to your calculator and put in the cosine of 5, and that'll give you your value of 0.284. So this one was a little different because you had to literally use the value from the table in your function to then be able to evaluate it. All right, let's try some practice problems from this guy. So I picked number 8 as my first one. And here's what you're going to do. You've got a limit as x approaches 1. Well, 1 is the guy that goes in the middle here. As you make your table, you're going to have to create your own table, and each table is going to be different based off of these. So put 1 in your table, and you want to take two values that are to the right of 1 and two values that are to the left of 1. So think about that on a number line. So the first one that you would do is 1 point, I don't know, we'll go 0, 0, 1. We'll go to the thousandths. And we're going to do a 1.1. Could you pick other numbers? Absolutely you can. It's just your chart is going to be a little bit different. So for now, let's just go thousandths, and then we'll go tenths for the other one. And again, when you do the homework problems, you can pick what numbers you really want to do. But I'm going to do thousandths and tenths. Now, if you think about that, that's going to put me, if I'm a tenth away from 1, I'm at 0.9. And if I'm a thousandth on the left away from 1, now I'm at 0.999. Kind of check what I did there. So my point that I'm looking at is 1. I want to go a thousandth to the right and a thousandth to the left. And I want to go a tenth to the right and a tenth to the left. And then I'm going to go to my calculator again. And I've got to put in our new function. Here's our new function. So I'll show you again. I'm going to the Gatorade button and F1. And it brings me back to the function I had in there. So I'm going to go up arrow and clear it. Up arrow, puts it, where am I here? Up arrow, clear. So you've got nothing in there, and now you're going to put in this big whopping thing. So open a set of parentheses, 5x caret 3 plus 2x caret 2 minus 13x plus 6. Close it up, divided by, open up new parentheses, x minus 1. Close it up. Press enter and make sure that it's input the way that you wanted. This time you don't have to go to table set. Your table is already ready for you to put in whatever numbers you want. So I'm going to do the Gatorade button in F5, and I can put in my values. So I put in 0.9, I put in 0.999, I can put in 1 if I want to, and it says undefined, which it should. Think about that back in pre-calc days. If you had a denominator that was x minus 1 and you put a 1 in there, you'd have a 0 denominator. You can't have a 0 denominator, so that's why it's undefined. And I wasn't writing down my things, but you are, 0.9 was 4.35, and then 5.983, then undefined, then 6.017, and 7.75.
Miss Winter,
Yeah.
I got really big values for my Y. When I put in the X values, I got like 85 and
You're like,
1,000.
whoa! All right, so here's what I would suggest. Go back and hit the Gatorade button and F1
Okay.
and see if you have the same thing that I've got going on here. Seems to me that you might not have had, that you might not have put the function in right.
Oh no. Yeah, I can't like pin the screen.
Okay, so let me ask this then. When you do your Gatorade F1 and it shows you what you put in for y equals,
Yeah.
does it look like the number 8 thing there, 5x cubed plus 2x squared minus 13x plus 6 over x minus 1?
Oh wait.
Yeah.
I think I missed the 13 and I just put in a 3.
Okay. All right.
I think that's probably it. And it's supposed to be like the y1 equals.
Yeah.
I can't see what
Yep.
Okay.
And that, yeah,
Alright, yeah.
when you look at the y1 equals, it needs to match what your number 8 thing says. And that's, if you're not getting the right values out, then it probably didn't get input quite right.
I I see. Yeah, I just missed the 13. I got
Perfect.
it.
You got it. Perfect. Good. Good question.
you.
It's the littlest thing that you can mess this all up. So I get it.
Yeah.
And you guys are also new to these calculators, so this is intimidating. It can be an intimidating calculator.
Yeah.
All right. So let's answer the question after all that. What's the limit at 1? Well, I check out what it's doing from the left of 1, and it's going really close to 6. To the right of 1, it's going really close to 6, and there's your answer. It's just 6.
I got the right numbers now.
Sweet. Okay. So you're good with the calculator and tables then. Let's go to number 10. And it says, use the given information to evaluate the limit. Round. We're going to round to 3 decimal places. He talked about that. That's an AP thing to do. So we're going to do the same thing, round to 3 decimal places. So the function's continuous and decreasing for x is greater than or equal to 3. Table gives the value of f at selected values of x. So they want you to approximate what the limit is as x approaches 5. Well, here's 5 right here. Right? This is where x equals 5. And if I look to the left and I look to the right, I get a y value of 2. Now y is the same thing as f of x. And so you're looking at this, I know what the limit is at 5, I'm going to just plug in what that y value, the f of x value is. So really what they want you to do is evaluate what e to the third and f of x is 2. So that means that it's e to the 6th. Now you can use your calculator. Actually, I'll show you again since we're new to these calculators. If I want to find e, you're going to hit the home menu under Gatorade. And you want the e, so that is, see where the x key is? Above it, the e to the x is in that green Gatorade color. So you're going to do the Gatorade button and then the x, and it gives you e with a caret. And we want to know what it is to the 6. So put a 6 in that open parenthesis and close it. Now it's going to probably give you e to the 6th. And you're like, yeah, I know, I've got e to the 6th, right? But if you want to know what the decimal equivalent of that is, hit that Gatorade button one more time and enter. And now it gives you the decimal equivalent of that. So my answer is 403.429. E to the 6th or 403.429. So if it ever gives you, like, you want the decimal equivalent, you just hit the green button and then enter, and it adapts it. Okay, let's see what else I got on the list today. Number 12. Same kind of question. These were a little goofy. Function is continuous and increasing from x is greater than or equal to -7. Table below gives you the values for f at selected values of x. So I'm looking at my x values, and they're looking at where x equals -5, which makes sense because that's what the limit is. So I'm right here looking at x equals -5, and I see that f of x, or y, is 3.999 to one side and 4.001 to the other. So f of x must be 4. And so what I'm going to do is then plug that in. So now I'm looking at evaluating this. I need the 5th root of f of x, which is 4. So how on earth do you evaluate that? The 5th root of 4. Now if you remember from changing roots to exponents, think about what it would be if it were a square root. You'd be taking 4 and you'd be raising it to the 1/2 power. This guy's a 5th root. So what are you raising it to now? And I know you all said the 1/5 power, right? Okay, so how do you put that in the calculator? So back to my calc here. I'm still in this home menu. I'm going to clear what's on the bottom. And I want 4 with a caret. And then I'm going to parenthesis this thing, because if I don't, it's not going to understand the right order of operations for this power. So it's going to be open parentheses, 1 divided by 5, close those parentheses, and it gave me 2 to the 2/5 power. And you're like, I don't know what that is. So do the green Gatorade button and enter, and there you go. It is 1.319, but I got to round it up, so 1.320.
My calculator skips that one step, so I don't have to do the Gatorade button again. Is
I'm
that
sure.
fine?
Yeah, absolutely, it's fine. It's probably in your mode that it is automatically putting you into a decimal form. So that's fine if it's not doing that. You're still getting the same answer in the end, right?
Yeah.
Cool. Yep, you're good. Okay, so one more question and then I'm going to let you go. And it's number 15. Because I thought this one was kind of hard. So if this bracketed x represents the greatest integer that is less than or equal to x, then the limit at 0 as you come from the left of 2 over the greatest integer x equals. And so in all of that, here's what the greatest integer graph looks like real quick. It's that guy that's a bunch of steps. If you remember him, he's that guy. And so if I'm looking at this, I don't know what this looks like. So what I'm going to do is I'm going to literally graph it in our calculator. So my task when I did this question was I used my calculator to graph it, and then I can figure out what the limit actually is. So back to the calculator here. I am going to go to the Gatorade F1. I want to go up to Y1. Clear out what I have. And what I want to do is graph this function right here, 2 over the greatest integer. And your calculator will actually do that. So if I put in here, it's going to be 2 divided by, and then I'm going to open parentheses. Now, are you ready to be mind blown? Because that's where we're going next. I'm literally going to type in alpha in int, meaning integer, int. So I'm going to hit the alpha button. I look for the I, which is the 9 button. So alpha 9. And then I want an N. So I'm going to do alpha 6. And then I want a T, and you'll see that there's no T down here, and you're like, yeah, where's the T? They actually have a T, X, Y, Z, T. Hit T. Open another set of parentheses. Put in an X. Close the X parenthesis, and then another closed parenthesis for the int part. So I'm hoping you can see what I've got on the screen there. That's what you want it to look like. Then you want to graph it. So you're going to hit the Gatorade button in F3. Mine looks like it's in a weird zoom here. Let me see. Zoom 6. Do you get kind of a disjointed, funny picture like that? All right, let's see if we can answer the question. The question wants to know, we've got it in here, what's it doing when I come at 0 from the left? So I want to think about a value that I'm going to check that's 0 from the left. If I have x equals, if I'm left of 0, that means I'm in negative territory, right? So I want to be something close to the left of 0. So I'm going to use negative, maybe I'll use 0.001. And see what y equals. So how can I do that? So I'm going to go back to my table, right? I can input numbers from the table. So Gatorade F5, and I put in negative 0.001, and it gives me a negative 2. And so can I now answer the question that they wanted me to answer? If this represents the greatest integer that's less than or equal to x, what's the limit as I come at 0 from the left of 2 over the greatest integer? And I get a value of negative 2, and you can see your answer is A. All right. I'm trying to find my purple paper. hang on. That's the last example that I wanted to do with you. So, I mean, if you have questions or whatever, we can keep, we've got a couple minutes, we can go do a little bit more, but here's where we're at right now. So some due dates for you to keep an eye on. Section 1.3, the problems are 1 to 5 with the test prep, TPs or test preps from 6 to 8. Those are due tomorrow. Wednesday, you've got section 1.4 you're working on, 1 to 12 with the test preps 13 to 15. And also before class on Thursday, you want to watch and take notes on the videos from 1.5 and 1.6. So that's kind of your week this week. At least until I see you again on Thursday. Issues, questions, problems, anything?
Miss Winter?
Yeah.
For number 11, I tried to input the LN thing into the calculator and it says that it's like a not real result. I don't know if there's a certain way you have to do it or...
Yeah. Well, so for that one, that's a good question. So I'm looking at number 11 with you here. You're inputting... It might not like the double negative because there ends up to be a double negative in this guy. So it's going to be the ln. And then I'm looking at when x is negative 3, my y is negative 3.5. So you've got this negative, and then you have another negative 3.5. So really what you're inputting is the ln of a positive 3.5. It won't like it if you put in a negative. So calculator, again, if I go to the home menu and go to LNs, LNs are the blue above the X. So I'm going to hit second and then X, and I'm putting in the ln of 3.5. And you should get a 1.25. 1.253. 3 decimals. Does that work better?
Yeah, thank you.
Yeah, no issue. It's going to take a while to get used to these calculators too. There's a learning curve to those, but again, once you get the hang of them, you'll love them.
Miss Winter.
Yeah.
In the video yesterday, he
Yeah.
talked about the 3 decimal places.
Yeah.
Do you have like a preference for whether we would round it or not?
I go with what Mr. AP tends to prefer, and that's rounded to 3 decimal places. So we're always going to be rounding to the 3 decimal places. He talked about truncating it. I think Mr. AP prefers the rounding.
Okay.
Okay?
Thank you.
You're welcome. Anybody else? All right. Have a wonderful day. Email me with any questions or any issues that you have, okay?